triangle known as the Pythagorean theorem. Remember that the Pythagorean theorem states that if A, B, and C are the lengths of the sides of a right triangle, where A and B are the legs and C is the hypotenuse, or the side opposite the right angle, then A squared plus B squared equals C squared is the relationship between the sides. Remember that this equation comes from the fact that the sum of the areas of the two squares that have side lengths A and B will equal the area of the square whose side length is C. If we are given two side lengths of a right triangle, we can use this property to find the length of the third side. Let's do an example. Find the length of the missing side of this right triangle. Since this is a right triangle, we may use the Pythagorean theorem. Notice that the side length that is missing is the hypotenuse because it is across from the 90-degree angle, and thus the longest side. So, in the Pythagorean theorem, x would be substituted in for c. Further, 6 and 4 are the legs, meaning they make the 90-degree angle, so they would be substituted in for a and b. Note that since a and b are both legs, 6 could replace either a or b. Similarly, 4 could replace either a or b as well. So we have 4 squared plus 6 squared equals x squared. Next, we simplify the equation and solve for x. 16 plus 36 equals x squared, so 52 equals x squared. To get x alone, we need to undo the squaring of x using the inverse operation. Recall that taking the square root is the inverse operation of squaring. Thus, taking the square root of both sides of the equation gives us the square root of 52 equals the square root of x squared, which simplifies to the square root of 52 equals x. So the square root of 52 is the length of the missing side. Let's do a slightly different example. You need to find the missing side length. Since this is a right triangle, we can use the Pythagorean theorem. Notice that this time the missing side length is a leg of the right triangle because it is a side that is connected to the right angle. So, in the Pythagorean theorem, x must be substituted in for either a or b. Notice that 4 is also a leg and must be substituted in for either a or b. Finally, 5 is the hypotenuse, so it must be substituted in for c. So we have x squared plus 4 squared equals 5 squared. Next, we simplify the equation and solve for x. X squared plus 16 equals 25. To get x alone, we must first get rid of the plus 16. Recall that if you have a linear equation, x plus 16 equals 25, you would use the subtraction property of equality and subtract 16 from both sides of the equation. We will do the same process here. So subtracting 16 from both sides gives us x squared equals 9. As we did before, to undo the squaring, we take the square root of both sides of the equation. The square root of x squared equals the square root of 9, so x equals 3. Thus, x equals 3 is the length of the missing side. In the task you did today in class, leaping lizards, you began to notice some properties of rigid motion transformations. In translations, each point of the pre-image moves the same amount horizontally and vertically. In rotations, each point of the pre-image moves around a center of rotation a specified number of degrees. The distance between pre-image and image points and the center of rotation stays the same as the object is rotated. Finally, with reflections, each point of the pre-image moves across a line of reflection so that the shortest distance between the image point of a line of reflection and the pre-image point of a line of reflection is the same on each side of the line. The shortest distance is measured along line segments that are perpendicular to the line of reflection. Use these ideas to help you translate, rotate, and reflect the pre-image dots A and B in your assignment. You studied graphing linear equations in Math 8. Recall that lines can always be described with an equation of the form y equals mx plus b, where m is the slope, or the ratio between the vertical and horizontal change, and b is the y-intercept, or the point where the line crosses the y-axis. This relationship remains the same, even when written in function notation. Let's do an example. Graph the function f of x equals negative 3/5 x plus 6. This function has a y-intercept of b equals 6, indicating that the line must cross the y-axis at y equals 6. So, to graph the line, we will start by plotting the point that we know it must pass through, 0, 6, and then use the slope to find another point on the line. Notice that this linear function has a slope m equals negative 3/5. This is our change in y over our change in x, or our rise over our run. So we can think of this slope as describing the change between 2 points on the line as either moving down 3 and to the right 5, or moving up 3 and to the left 5. Note that we can only use the negative sign once, either with the change in y or the change in x. If we choose the negative sign to go with the 3, we will move down 3 and right 5 to find another point on the line. While we can continue to plot additional points on the line, 2 points are sufficient to determine a line, and so we can draw a line through the 2 known points and know we have graphed the correct line. Lastly, when identifying similarities and differences between 2 functions, key features that could be considered but are not limited to consist of the following: whether the functions are increasing or decreasing, their rates of change, if linear functions are parallel or perpendicular or neither, their x and y intercepts, and the continuity of each function.